Okay, so for this question, they were given sorted to the matrix, and the integers in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. And so are the elements in the given matrix unique? No. Okay, so which means that there may be multiple results in the given matrix. So, but it's fine, right? Like as long as there is at least one target, one element whose value is equal to the target, then we can just return true. Yeah, and yeah, okay. And can I assume that the input matrix is valid? Like, how about it's a null object, or it's an empty matrix, or it doesn't has any columns? Yeah. So in that case, we will just return false. All right. So for this question, um, because we know each row is sorted, and for each row, its first row is always greater than the last integer of the previous row. So we can know that each column is sorted as well. So for this case, we can see this sorted matrix as um, as a sorted 1D array which positioned as a matrix, and we don't need to actually create an extra 1D array. We can just map the 1D the theoretically 1D array coordinate to the actual 2D matrix coordinate. Yeah, so let's see. So now if we have 9 elements, what is this? I don't want this. Okay, so let's say now we have 9 elements. I have 9 elements here. Then in the theoretically 1D array, its 1D coordinate should be 0, 1, and 2, and 3, and 4, 5, 6, 7, and 8. So as we can see, its 1D coordinate index should be because 3 can be viewed as 3 minus 0, and here 3 minus 1, 3 minus 2, and here is 6 minus 1, 7 minus 6 minus 1, 6 minus 2. So the 1D index could be the row value times the column number, or the column length. Like in this case, it's 3, and plus its column. So we can just run an ordinary binary search on this matrix only to convert its, only when we're trying to get the value in the middle element, we can just, so like we can run the ordinary binary search on the 1D theoretical array, and only to convert this 1D index to 2D index when we're trying to get the middle element value. So, and then in this way, we're actually running an ordinary binary search an array with length m times n. So the total runtime will be log m minus m times n, and that is it. And I think another solution would be, we can, because we know each row and each column is sorted, so we can discard a row or a column at one time. And maybe another solution is that we can search the rows at first to see in which row the target might be in, and then we search each column to see in this row where is our target can, like where our target can be. And for this solution, the total runtime will be log n plus log m, because we're running 2 binary search. Well, so I think for these 2 ways, they should be the same. Like the runtime should be the same, because log m plus log m actually equals to log m times n. So I think the runtime should be the same. I think the difference might be when the target value does not exist in the matrix. Then in the second solution, we would only run 1 binary search. After we run the first binary search, we can already know for sure that this target cannot exist in the given matrix. Then we won't need to do the second binary search anymore. And in that case, the runtime of the second solution might be log n or m. So that is probably when the second solution will be better. So I think we can try both solution. Okay, so now let's do the first solution. Alright, so as usual, first of all, we will have a solution class. Wait, I need. Alright, I'll use this one. Okay. So this is the first solution. Class, we will have a class solution. And here we will return a boolean. And let me see what's okay. Let's just call it find, and we're giving a 2D matrix and the target value. Then we're gonna run some sanity check to see if the matrix is valid. Then we will return false because it's impossible that there is any target value in the matrix. And then so we're just gonna run the usual binary search, the ordinary binary search on this, only using the theoretically 1D array index. So well, I think we will get the column length and row length first. Will be much more convenient. So the row length should be matrix length, while the column length will be the column length. And then so we will initialize the left pointer to 0 and the right pointer to row length times column length -1, and then run the binary search while left less than or equal to right. Then get the mid value. Well, we can write it in this way to avoid the integer overflow. And then get the current value, and so now we're convert 1D to 2D. So the mid index, so the column should be mid index divide over column length, and its column number should be mid mod by column length. Yep. And then we can compare the current value with the target, and if it's the same, then we just return true because we've already find it. Else, if it is smaller, the target is smaller, then we can find it. We can find the target in the left half by decrease it to mid. 好。好。Then else, if it is larger than the current value, then increase left to mid +1. And after we're done this loop and we're out and we still haven't find any, then we can return false because we know the target does not exist. Yeah, and then let me do some arrow check. Nope. Length. Yeah, should be fine. Okay.